Good morning students. Today we are going to discuss about the paper 4th, practical 4th of the paper 4th, that is industrial hygiene and chemical safety. So today we are going to complete at least the minor experiment of the paper 4. We know that the minor experiment normally it is consisting of first experiment, that is preparation of the material safety data sheets for common chemicals. So we have to enlist certain common chemicals, example for ethyl alcohol, chloroform, potassium dichromate. These are certain chemicals which are used in the laboratory most oftenly. So we have to prepare the material data sheet. Means what? We have to prepare the information related to the certain chemicals, that is said to be the material safety data sheet. Means how to handle these chemicals is written in that data. And next experiment, that is to neutralize the given sample using the NaOH, HCl or CaCO3. So in most of the factory you can find out the wastewaters are liberated and these wastewater are to be neutralized. So in order to neutralize the wastewater, we require either the base, strong base or the strong acids. And how to neutralize this wastewater by means of base or the acid can be seen in this experiment. So the name of the experiment is to neutralize the given sample using the NaOH or the HCl. Next, third experiment, that is determination of carbon dioxide from the atmosphere by volumetric method in the workplace environment. Here this experiment is repeated as we have already covered this experiment in SEM 2, or I think so in the MSc EVS part 1. So we are not going to repeat it, but we are going to perform these three experiments, that is experiment 1, 2. So just go through this experiment, that is determination of carbon dioxide from the atmosphere from the last year journal. So what are the permissible limit of carbon dioxide, how the volumetric sampling is done, and what are the different ways of calculating the carbon dioxide, what is the percentage of carbon dioxide present in the atmosphere. So this is the only the viva related to the carbon dioxide. You go through it. Today we are going to perform only the two experiments, that is the material safety data sheets and the neutralization by means of NaOH and HCl. And tomorrow you are going to complete the syllabus by means of doing these two experiments, that is third one, enlisting the characteristic advantages, disadvantages of PPE, personal protective equipments, and NR PPE of any industry. So we have to find out what are the importance of PPE and NR PPE, what are the characteristics, what are the advantages and disadvantages of these two things. As well as we have already covered this portion, this is air sampling of gases. We have already did this experiment in semester first or second, I think so, semester second, that is estimation of sulfur dioxide and NOx, SOx and NOx. So this experiment is already done in the first year, so we are not going to repeat it once again. So air sampling, their calculation, what is a permissible limit, you just go through the permissible limit of the SOx and the NOx. So today we are going to perform these two experiments, that is preparation of material data sheet and the neutralization of the given sample. So the name of the experiment, that is prepare material data safety data sheets for some common chemicals. So we are going to discuss certain common chemicals. These chemicals are These chemicals are ethyl alcohol, sulfuric acid, chlorides, zinc sulfate, hepatohydrate, potassium dichromate and chloroform. You have heard of these chemicals which is oftenly used in the laboratory. So we are going to prepare the material data sheets of all these chemicals. So what are required for preparing the chemical data sheets is mainly the general information. So the requirement is the general information. So it will include the general information. It will include the physical and chemical properties of that particular chemical. Third is the stability, and fourth is the toxicity. So a particular chemical information related to the information is kept under this sheet. That's why they are said to be the material safety data sheets. So all information regarding the chemicals is stored or it is maintained in a particular booklet. And regarding the hazardous or toxicity or stability, it is already informed inside the safety data sheets. So today we are going to study only the two chemicals, that is the ethyl alcohol and the chloroform. So ethyl alcohol, when we are going to prepare the material data sheets for the ethyl alcohol, we have to write the first step, that is the general information. So what is the general information related to the ethyl alcohol? That is synonyms. So what is the another one more name which is given to the ethyl alcohol? That is, it is also said to be the ethanol, or sometimes it is also said to be fermentation alcohol, methyl carbinol, absolute alcohol. So it is known by various names like absolute ethanol and hydrous alcohol. So you can say that these are the different names by which it is identified. So ethyl alcohol, synonyms of the ethyl alcohol, it comes under the general information. Next, coming up to the formula, we have already seen that each chemical had a particular formula, and that should be entitled on the top of the bottle or on the bottle. So the molecular formula, that is C2H5OH. This is a molecular formula of a given chemicals. Next, CAS number. This is nothing but the registry number, which is normally of the 5-digit number. So registry number, that will be month, year, etc., etc. So it is nothing but the registry number. Next, coming up to the EC number. EC number is nothing but the European Community Number, and it is the unique 7-digit identifier that was assigned to the substances for regulatory purpose within the European Union by European Commission. So you can say that this is a 7-digit number which is given by European Committee. That's why it is said to be the European Committee number in order to identify the chemical. Next is the index number. So we have to prepare the material data sheets of the alcohol. So in which we can find out the first step, that is the general information. So we have already prepared the general information by means of synonyms, by means of including the molecular formula, CS registry number, EC European Committee number, and in the index number. Next, coming up to the next topic under the preparation of material data sheet is that first topic we know that is the general information, and next one we know it, that is the physical and the chemical properties and chemical properties. So what does the physical and chemical properties shows of that particular ethyl alcohol? So we can say that the appearance, how does it look like, So when we used to identify a particular chemical, then we used to find out how is the appearance. So the appearance, that is colorless, 78. Melting point is also indicated over here, that is 144 degrees centigrade. Boiling point 78 degrees centigrade. Specific gravity 0.789, vapor pressure, that is 1.59, flash point 1.146, 146, auto ignition temperature, that is 363 degrees Celsius, and explosion limit 3.3 to 24.5 percentage. Water solubility miscible in acid proportion. So these are certain physical and chemical properties, or you can say that the chemical or the physical character of certain chemicals, of that chemicals. So we have here seen the chemical property and the physical property of the ethyl alcohol. So at which temperature it melts, at which temperature it boils, at which temperature it explodes, what is the flash point, vaporizes, at which temperature it used to vaporize it, at which temperature it becomes soluble in water. So you can say that these are the certain physical and the chemical property of the ethyl alcohol. Next is the risk phase. So first one, you know, it is general information. Next one, that is physical and the chemical property. And third one is the risk phase. So what are the risks related to the given chemical? So risk 2, that is risk 1, it is highly flammable. Next, risk 2, that is harmful in contact with the skin. So when this chemical comes in contact with the skin, it is considered to be harmful. That's why it is said to be risk factor 20. Risk factor 21, that is irritation of the eyes. So if you come in contact with this ethyl alcohol for a long duration, you will come to know, you will face the irritation of the eyes. Risk factor, that is 36, that is irritation to the eyes. 37, that irritation to the respiratory system, and risk factor 38, that is irritation to the skin, and risk factor 40, that is limited evidence of the carcinogenic effects. So these are the certain risks which are related to the ethyl alcohol. So we have seen general information, we have seen physical and chemical characteristic, we have seen the risk factor related to a particular chemical. Next, fourth step, that is safety phases. So first is the general information, second one is the physical and chemical characteristic, third one is the risk factor, and the fourth one is your safety phases. Safety, what are the safe precautions we can take while handling these chemicals? So safety phases is S7, that is keep container tightly closed. We have to, because there are certain risks related to this chemical, so we have to keep the container tightly closed. Next, S16, safety factor, that is 16, keep away from the source of ignition, because it used to explode, it has a flash point of 146, it can catch fire easily, that's why we have to keep away from the source of ignition. S24 says that avoid contact with the eyes, because when it comes in contact with the eyes it causes irritation, so it should be avoided with the contact with the eyes, or one must wear the goggles in order to avoid in contact with the eyes, or we have to take certain safety precaution of the eyes in order to avoid irritation of the eyes. S36, ears, we have to wear certain suitable protective clothing for the, so this is W, wear. So this is S36 is wear suitable protective clothing. Means what? While handling these chemicals, we have to wear certain protective clothing in order to avoid the risk. S37 says that wear suitable gloves. So we have to also wear the gloves S39 says that wear eye and face protection. So we have to protect the eyes as well as the face. So what are the risks which are related to the ethyl alcohol and how to avoid this risk by means of safety precautions can be seen in the safety phrases. Next, S45, in case of accident or if you feel weak, seek medical advice immediately. So if you comes in contact with the ethyl alcohol and if you feel weak, then we have to go for the medical advices. So that is S45. What to do if you face certain uh, symptoms related to the related alcohol. So these are the different informations regarding the chemical. In this way, we have to prepare the material data sheet of the 6 chemical. So you just know what are the different type of chemicals which are used in the laboratory and how to prepare the material data sheets of all these chemicals. That is an important factor. So next, coming up to the stability. So stable substances to be avoided include strong oxidizing agent, peroxide acids, alkali metal, ammonia, acid chlorides, moisture from the explosive mixture with air and hygroscopic. It is said that how to make this ethyl alcohol stable or how this stability can be maintained. So this stability can be maintained by means of avoiding with the oxidizing agent. Should not keep this ethyl alcohol with another side by side with another chemical like oxidizing agent. So if certain oxidizing agent is side by side besides this ethyl alcohols, though it may be reactive. So it is said that in order to make this chemical stable, we have to avoid keeping certain oxidizing agent, peroxide acids, alkali metal, ammonia and chloride, moisture from the explosive mixture with the air hygroscopic. So we must avoid keeping this or certain chemicals besides this chemical, so that this chemical remains stable for a long duration. So we have already seen the general information. Similarly, we have to prepare the material data sheet for the chloroform, next potassium dichromate, etc. etc. So we have seen that in case of the preparation of material data sheet of any chemical, we have to write the 4 things: general information, physical and chemical property, stability, toxicology if it is present, then risk phases, safety phases and stability. Next experiment, that is to determine the amount of NaOH or HCl required for the neutralization of an effluent. So here the main principle is that any wastewater is given to you and the acidity or basicity will be checked first. So the main principle of this experiment is to acid reacts with the base to form salt and water. We know that when acids reacts with the base, only 2 things are formed, that is salt and water. Salt and water. So here when this acid base reacts with the acid, we can find out there is a formation of salt as well as the water. And here what is the requirement for this experiment? What we are doing, we are just neutralizing the given wastewater. So first we have to check the pH of the wastewater. Consider a particular water sample is given to you, wastewater sample is given to you and its pH is 4. So if the pH is 4, we can say that this water sample is acidic. Okay, so this is an acidic sample. Or now what we have to do is that we have to maintain the pH. We have to increase the pH till 6 to 7. Consider we have to increase the pH till 7. So what we have to do is that we have to add the base. We have to add the base. So that while adding the base, we can see that the pH increases from 4 to 5, 5 to 6 and 6 to 7. And this way we can say that the pH can be maintained. Consider if the given pH of the wastewater is already 10. I say if the given water pH is already 10, now we have to reduce the pH till 7. We know that most of the molecular or the organism biological activity can be seen in the pH 6 to 7. So we have to make this pH from 10 to 7. So what we are expected to add? We are expected to add the acid. So we are going to add the HCl. A known concentration of HCl is added to it, and then we can bring this pH from 10 to 7. So as soon as we are going to add the HCl, particular amount of HCl is added, its pH comes to reduces to 9. Again, if we add the HCl, then it reduces to 8. Similarly, we can get the pH 7. This is nothing but the neutralization of the effluent. So what we are doing, we are just maintaining the pH by means of adding the NaOH or the HCl. So the amount of NaOH or HCl required in order to neutralize the effluent, that can be determined by this experiment. So what are the requirements? The requirements are pH meter, beaker, 5% and 10% of the NaOH. So a known concentration, I said, that is 5% and 10% of NaOH is required. Similarly, 5 and 10% of HCl is required. Or you can say that base of 5 to 10% and acid of 5 to 10% is required, as well as the effluent is required. The effluent may be acidic or it may be basic. So if the effluent is it depends on industry to industry, and the effluent may be acidic or basic. So first we have to check the acidity or basicity of a given effluent, and then we have to perform the practical. So first, the initial pH we have to check. Consider the initial pH is 10. That means we have to add the acid. So after finding out the initial pH of the given effluent, we have to take the decision. Why? Either we have to add acid or we have to add the base. So next, procedure. So we have to take 100 ml of the given sample in 250 ml of a beaker. So we have to take the 100 ml of the effluent. So consider if it is a beaker. So in this beaker we have taken 100 ml of the effluent. Check the pH of the effluent. We have to check the pH. Consider the pH. Add given acids or base solution to the pipette or bead till it becomes range 6 to 8. So consider if the pH of this effluent is 10 pH. So we have to add the acid. Okay. So we have to add the acid. We have to add the acid, that is 5% or 10% of the HCl drop by drop, so that its pH should come to 6 to 8. And the amount can be said that the given sample in acidic. So the given sample is acidic and requires 0. कितना ml आपका HCl यूटिलाइज हुआ है या NaOH यूटिलाइज है, that can be written as a result. 0.2 ml of 10% of NaOH solution for neutralization of 100 ml of the effluent. So what amount of the NaOH is required in order to neutralize this sample can be written as a result. So today we have completed the minor experiments of the paper 4 that is industrial hygiene and chemical safety. Tomorrow we are going to complete the syllabus by doing the two main experiment, that is the PPE and NNR PPE. Okay, thank you, see you tomorrow. And very soon we are going to complete the practical exams. So most oftenly after 5th or 6th 5th December you assemble, will conduct a let me know, will conduct a practical exams. Thank you, see you tomorrow.